is.
Okay.
Another thing we're gonna be doing differently is for the level control. You're gonna be closing these valves instead.
Let me
And when
look.
you're restarting it, you're gonna be reopening this valve.
Which valves?
These four.
Okay.
But for restarting, we're gonna use the startup isolation because we have a way finer control here.
I understand.
So pick your Scram Quick card and remember step 2.3. I'm gonna read back before you continue with the procedure. Got it?
Yes.
Okay, now Brakeman scram the reactor.
Unders-
PPM 331.
Understand scram the reactor as per ppm 3.3.1.
Yeah, that's correct.
Mode switch and shutdown. APRM's not downscale. RPV pressure 1010 pounds down slow. RPV level 17.5 inches up slow. There are no EOP entries. Or no, there
Okay,
are.
there's actually one EOP entry.
It's
One that I didn't talk about. There's an EOP entry for scram required with power greater than 5%. So mode switch and shutdown, APRMs are not downscale. Reactor pressure 1010 psig down slow. Reactor water level 17.5 inches up slow. EOP entries on reactor scram required.
That is correct. All rods are not in.
That is after ARI SLC now.
I'm initiating SLC. SLC, I cannot initiate SLC.
Did you initiate ARI?
No, I did not. Now I'm initiating SLC.
Okay, you're initiating
I
SLC.
still cannot. For
Okay, what's the flow and initial tank level?
SLC is still not initiated.
What is the initial tank level?
Initial tank level is 475,000 gallon or 475,000 gallons.
4750 gallons.
Oh.
And flow is
Flow is 0.
0 GPM. You report the thing even if it's 0.
I see.
Okay, so SLC is initiated. Initial flow 0 gallons per minute. Initial tank level 4750 gallons.
That is correct.
Okay.
All right.
Verify valve 4 closed. Or WC valve 4.
Where's RWCU V4?
In isolation controls.
RWCU V4 is open.
Then take manual action.
I'm taking RWCU V4 to close.
Yeah. So you're closing your WC valve 4.
Stand by 1 second. My mom just threw something at me because I guess she wanted to give me some. Yeah, she wanted to give me some. Okay, we are in Atlas at greater than 5% thermal power. CRS, I'm awaiting instruction.
So when you stopped valve 4,
Mm-hmm.
you have this alarm for flow low and the pump tripped. So you can now say the thing actually isolated.
Oh.
Valve 4
RWC,
is drawn here,
RWC
actually.
V4 isolated.
Mm-hmm. Okay, subsequent actions for the BOP. Override the CCS. I'm gonna do the BOP stuff now because I didn't do this later. Override the CCS. Override MSIV isolations. Inhibit ADS. And that is it for now. So basically, at this point, what the BOP does is he overrides all of injection. RHR, lip kiss, and hip kiss prevents MSIV closure and prevents ADS initiation.
I see.
Following the subsequent actions, you should also insert IRMs and SRMs now.
Understand you would like me to insert IRMs and SRMs fully at this point.
Yes. No, you should also note that before inserting IRMs, you should range them to the maximum range. You're gonna be reducing the ranges as you go. This way it doesn't fry the sensor instantly. Okay, so we're now entering 511 RPV control. Mode switch is already in shutdown.
That voice crack
ADS
is
is
crazy.
inhibited.
I said that voice crack is crazy.
Okay. Prevent empty tripping by closing RCIC valve 1. You there?
Yes. Sorry, read that back.
Prevent empty tripping by closing RCIC valve 1.
Understand prevent MT tripping by closing RCIC V1.
Yeah, that's right.
Tripping RCIC or closing RCIC V1 with manual trip push button. RCIC V1 closing at this time.
Alright. Now, one last thing I want to try doing before we reduce level is reducing power significantly. So can you...
SLC systems A and B are still in the operating mode, even
It's
though.
fine.
Okay.
They should be. Alright. Can you stop recirculation loop Bravo? Just Bravo for now.
Understand. Cease pumping on RRC Bravo.
Yeah, that's correct.
Oops.
Take a quick look at reactor power. I mean, electrical power.
I see.
Yeah, it is quite significant. Now stop alpha.
Understand. Stop pumping on RRC Alpha.
Yeah, that's right. I want to see if significantly reducing the power is enough for preventing the turbine from tripping.
It does not appear to be because we're at. Oh, it's plateauing now.
The reason for the turbine trip before was condenser vacuum breaking at -50 when circulation water trips. Okay, we reduced power below 1/6 of what is rated. So let me see what happens now if I stop one circ water pump.
I'm continuing to range IRMs down.
Mm-hmm. Okay, yeah, now it actually maintained the vacuum. Let me see what happens if I trip the other one. Yeah, that's fully fine.
Wait, should I insert SRMs and IRMs fully, or just range SRMs and IRMs within their limits?
Insert fully, but range IRMs within their limits.
Understood.
SRMs are gonna fry.
Get
It's
blasted.
fine.
I mean, in real life, the SRM probe is easily replaceable, right? It
Yes.
shouldn't matter.
You're, on an event like this, you're gonna disassemble the entire reactor anyway.
I don't think you're gonna. Or I think replacing the SRM thing is a little bit tedious to do, or expensive. I forgot.
Well, it's less
It's a few
expensive.
$1 million,
Less expensive than the
which
new
is
reactor.
insignificant. It's a few $1 million, which is insignificant in relation to the entire reactor being checked.
After this, the reactor is probably gonna be decommissioned. Doesn't matter anyway.
Exactly. Okay, Nog, so testing. I already tripped both circ water and the thing didn't trip. And yeah, you have to lower power a lot. This will also.
Your microphone's like bugging out a little bit.
Okay, is it better?
Yeah.
Yes.
So, yeah, we reduced power a lot, and I already tripped this manually, and the thing didn't trip. But if we were lowering level and it got to -50 prior to power being significantly reduced, then the main turbine would trip.
What are my appropriate actions now?
Stop and prevent condensate and feed.
Understand you would like me to stop and prevent condensate and feed water flow until
Yeah,
minus.
you can just
Okay.
you can finish 332 now. So that would be step 312.
So 312 is finished?
No.
No.
You're
Oh,
at
312,
Bravo and Charlie.
312 Bravo and Charlie. Understand you would like me to stop and prevent injection until minus 65, then establish and maintain between minus 140 and minus 80.
Yeah, that is correct.
Understood.
So for this control, it's a bit hard. This two shouldn't be closed.
Which
Just
two?
those four.
Oh.
This two. So now level's gonna drop a lot. Also, the pump will probably try to speed up, so maybe put them to M them.
Both pumps and end them.
Now monitor level, you can have the GDS up as well in core cooling. Or you can use the wide range, but the wide range is wide, so it's hard to read. Okay, basically your pumps are already in manual demand, so they're not speeding up, and they are not spinning that fast. What you're gonna be controlling for level control is basically these two valves. So the startup isolation and the flow control valve. Both of them are throttable. The startup isolation is throttable here, and the flow control valve is throttable here on the startup level
I see.
controller. You are required to have, since we're isolating by using these 4 valves, you are required to have them closed above -6.5, and you may only start opening them once you're below -6.5. However, the flow control valve is not part of what's currently guaranteeing isolation. So if you desire, you can place your
HPCS is
startup
actuating
controller.
again.
Yeah, but it's inhibited this time.
Okay.
So what you can do is placing your feed water startup controller to manual and open it slightly to like 25%, for example. You should be focusing on level, ignore the other things. Over here, 25%. Or a bit more, it's fine. And now take level control by throttling this valve. And look at level, especially on the GDS. You don't want it raising too fast. If that valve fully opens and the level is still going down, then you can open more of the other valve. Yeah, you can keep opening it while the level is going down. Okay, it's fully open. Your level is still going down, so
Yes.
open the here more. The startup more. And monitor your level until it stops going down. Oh, god damn it. I didn't realize these 2 valves were closed. This is my bad. Monitor your level, it's gonna spike up really fast.
Holy. Okay.
So,
Level is
yeah,
responding minus 107.8 inches up slow. I didn't realize our turbine was still running. That shocked me. Startup level controller is full open, and we are stable at minus 110. We are up very, very slow, actually. Why is nobody speaking?
we are in DMs.
Oh.
Okay. So currently is everything under control? Power,
Yes.
pressure, and level.
Power pressure and level are all stable.
Very good. So usually at this point, in this situation, you would have ATC, so you controlling level, BOP controlling pressure, and at this point, CRO3 would then step up to control power. Make sense?
So I'm sorry, could you read that back? I blinked out.
So out of those three parameters,
Mhm.
during a high power ret loss like right now, ATC would be focused on reactor level. And this is your main focus until this event ends.
Okay.
You're gonna basically keep an eye on level at all times. We are decently close to top of active fuel, and this is why it requires constant supervision. BOP would be doing pressure, reactor pressure, as well as a bunch of other things. And CRO3 would then be handling power, as well as a bunch of other things.
Okay. So currently my only concern is level.
Exactly.
I understand.
Also, it's important to note that even though it is a very critical event, currently we have basically everything under control. So there's nothing to be panicking about. Apart from high power and low level, there are no EOP entries basically. So what I mean by that is the primary containment, it's not ignoring this level. Ignoring the 0.06 inch that we are above in the narrow range.
That's 2.06.
Yeah, 0.06 above the entry
Oh.
and stable. The entry is 2. But what I mean is like there's nothing of major concern happening here. Like no value is changing basically at all. And apart from this, which is insignificantly above the desired level, everything is within desired level.
I understand.
Okay. Let us continue. So for reactor power, we're basically missing a single ppm that 03 would be doing. For reactor pressure, it asks us to restore and maintain between 1060 and 350, so it's a huge band, and we are within. So pressure is also good, there's nothing to do. And for level, it is a bit more complicated. So for level, we're gonna be restoring and maintaining level between minus 186, but preferably TAF. We don't want to go below TAF. And lowered level. So you know what lowered level is?
Minus 65.
Initially, yes. But as you lower it, it's gonna lower more. So what is our current level?
Oh, minus 107.
Minus 107. The reason we lower level at all in the Atlas is because the lower the level, the lower the reactor power for nuclear reasons.
Oh, I see.
And for this exact same reason, we don't want to be raising the level again. So you're basically gonna keep between TAF and minus 107 now. Don't go above minus 107.
Understand, keep between TAF and 107.
Yes. And it is preferred to use the preferred injection systems.
Using preferred
per
injection.
usual.
Okay.
Yeah. I'm gonna send you the table of the preferred injection systems, but just know that the top one is feed water, so the one we're using.
I understand.
Here's the list in order. So feed water, RCIC, CRD, condensate, Hipkiss, Lipkiss, RHR.
Oh, yeah. So currently we're injecting with condensate. Is that correct?
We are injecting with reactor feed water
Oh.
and CRD.
Okay, so
Condensate is technically the water is going through the condensate pumps, but saying it's injecting with condensate would mean the feed pumps are not running.
I see.
So using the condensate and condensate booster. That is a low pressure system. It only works below minus plus 350 pounds. Less than that, it's not going to inject. More than that, goddammit, I'm saying it all wrong. Next thing we should do is verifying the actuations.
Sorry, could you read that back? Your microphone is like glitching out.
Okay, I moved my microphone a bit. Is it better now?
No, you sound like a robot.
Alright, I moved it further. Is it better now?
That's marginally better.
God damn it. Let me test real quick. Oh, my connection is also really bad, so that's probably why.
Ah, I see.
We should now verify our actuations. +13, -50, and -129. Reactor level. Jay Woo, can you do that? Do you know how to do that?
What?
Verify each of the following actuations that should have initiated but did not for +13 inch and -50 inch.
Wait.
There are 3 things you're gonna be
ver-
looking for.
Can
Yeah,
someone
repeat.
find whatever back panel is an alarm and acknowledge and reset it? Because it's very annoying.
You can repeat it.
Verify RPV level 50 inch and what else?
+13 and -50 inch actuations. Did you get that?
Verify. No, I couldn't.
Is my mic that bad?
No, I'm just bad at listening.
Okay, verify the +13 and -50 inch actuations.
I
Okay,
really
verify
should plug my phone in.
1 + 3 and -50 actuations.
Yeah, that is correct. Do you know how to do that?
It's in the phase automatic actuations quick card.
Yeah, that's one of the 3 places you have to look.
Oh, it's more. Oh my god.
So quickly in game, without even leaving the game, you have this to look at some of them. So +13 -50. In this case, it says -51. RPS trip. Did the reactor trip?
Yes.
Nice. ADS permissive. This you check on the back panels. Over here, low level,
It's lit up,
And-
so yes.
and on the other side for the other division. Check that one.
Yeah.
Alright. Still in game. RWCU isolation. That should be RWCU valve 4. Did it isolate?
Yeah. What about
Nice.
valve 1?
It also isolated. So it's fine. And ECCS initiation. But -50 is the fast, so it's for -50 we can just check the A signal. Apart from the A signal in the fast, if you look in quick questions, look in the pin messages in quick questions.
Yeah.
Scroll all the way down. There is a thing from Marcy that says +13 -50 -129 showing isolation controls.
What's
actually-
ADR and FDR?
Equipment drain radioactive, floor drain radioactive. They're not simulated in the isolation controls. But anyway, look at the +13 and the -50. All of those should have closed.
I think last time you read it
We
wrong,
did.
so just to be sure, everything that's highlighted should be shut, not open as it shows in the picture.
Did they say open?
I think they showed open in the photos.
No, they show closed on the picture. Oh, except the MSIVs.
Yeah, that.
There is also another note. Okay, did you verify the thing?
Yeah. We're all like the Pixars.
Okay, the desired ones are all closed. There's just one note for -129. Is during a high power ret loss, you're not gonna be closing the MSIVs to keep the main turbine as your
Turbine.
heatsink.
Yeah.
I think you can close the drains, right, Ornog?
For what?
-129 during high power ret loss.
Steam line drains?
Yeah,
Yeah.
they
all of them
they
are.
should close. Yeah. So yeah, so the only exception for those pictures is MSIVs during at loss. The rest you follow.
I mean, yeah, it depends. If it's an Atlas, then I probably would keep the drains open. It depends. But most of the time, probably not.
To be honest, yeah. Oh, I also realized on that exact same message below it is the quick card as well, the fast quick card.
Bro,
Yeah.
can someone pull the breaker on P603 alarms? Jesus Christ.
Here, you could just just click on another board. It just silences that one.
Oh.
Well, the recent horn's still there. But I was gonna say, Vale, I think right now I would open them and just like prop it open on the low power drain.
I don't know why we even closed them. Why do we close them?
The 1.6 and 1.9.
Yes.
Like, why do we close them?
Yes.
Or why did we close them?
Yeah. Why does power operation have them closed at all?
It's so that I remember I asked this question.
CRS, what am I doing right now?
Controlling level.
Am I just waiting for next instructions?
Do we tell him Dornog?
Up to you.
That is the last instruction. Yeah, ATC basically just controls level during the loss. After the high speed, reducing power, reducing tripping, scramming, reporting, SLC, ARI, IRMs, SRMs, then it's just controlling level. To the rest of time.
So are we gonna depressurize?
Okay. Not with the reactor online. Remember, the reactor's still running.
So Vale.
Oh yes.
Yeah.
Sorry, you guys can finish. Are you done?
Yeah, I was done.
Okay. There's no operational guidance to not use them, but it's to prevent potential steam line leaks, so that there's no like points of failures.
That was like my reason that I gave based on literally nothing.
Yeah, so there's not like more points of failures. And the well, let me just read what Enthalpy said.
He
said
said they
yes.
leave it open.
But they don't need to be.
One thing that he does say is that those valves should, if I remember that exact conversation, you shouldn't be moving them if you don't have to, if you don't have a reason to move them, because moving them can leak steam.
I would open them in this context, in case like the MSIV is closed, or something happens with the turbine.
So how are we gonna get reactor subcritical?
There is a PPM for that. I can have you do it actually, but let's just finish checking the actions now.
I was gonna say normally for this situation you'd poison the reactor using SLC.
Well, SLC is
Yeah.
inoperable apparently because it's an
Yeah,
op.
that's why I said normally. I saw it had zero flow and the valves are shut. And alternate insert rods with the PPM
Yeah.
I think it's pulling up.
We're gonna insert rods alternatively.
Actually, we
Yes.
can probably show them the power leg Val of if I want to.
Yeah, but I just want to finish actuations first. And then we move on to that. So let's go back to that thing with the FAZ, or just open your own FAZ. It's the same thing. So Jay Woe, it's a question for you. What signal we have, FAZ or multiple?
It's wait 1 second. I think it's only A.
Yeah, you're correct. Only A. So, top to bottom, let's check the things that say A. Hipkiss diesel start and Hipkiss pump 1 start. Did those happen?
Yeah, but I manually overridden it.
Yeah. You can, it doesn't require to be running if it's manually overridden. So don't restart the pump when you're checking actuations if you see the manual override. This is valid for basically all the pumps. How can you be sure the diesel is running?
I turned it off manually. So
Did you turn the
this.
diesel off?
The diesel or the pump?
Oh, I was talking about the pump. Like, turn this and click it and incorrectly close this.
Yeah. Vale is asking about the diesel, which is running.
Oh,
One indication.
Yeah. You should always verify with the actuation, with the indications. Okay, following the thing, what's next?
LT. Travel EDR and FDR some isolate.
Yeah, EDR, FDR. Where? It's written in the document. H13 refers to panels.
P601.
Yep.
They'll be
it's
right there,
not-
but they're not simulated.
They're not simulated and you technically checked them. They are in the Marcy's sheet as well. Alright, next.
By the way, in real life, see that last column? You would actually check these off as you go, so you can actually keep track of this.
RCC sample lines isolate.
Panel 601 as well.
Yes.
Mm-hmm. RWCU isolates. You already checked that. RCIC starts. This is a tricky one.
When the turbine RPM is 0.
So
Yes.
I currently
Why?
have music playing in the background. If you need me, say my name and I'll lock in.
Okay, it's not running. So should you fix it and place it to run?
Yeah, because it's not manually overwritten.
It actually is. The initiation sealing is sealed in.
Oh,
Basically RCAC during a high power at loss is manually isolated, so the main turbine doesn't trip. So this is an exception, but you can mark it as initiated as the logic initiated. Next, RRC pump trips,
Yes.
RWC pump trips. That's RCC you're looking at.
oh, step before it said to check RCC2. And the RWCU pump are tripped.
Okay.
Reactor scram. Yeah, reactor is scrammed.
Circ water, 1 Bravo and 1 Charlie trips.
They are.
If both turbine service water running, transfer to Bravo. This is not simulated, but basically it would. Oh, sorry, Bravo trips if both are running. Okay, that's page 1 done. Page 2 now.
Division 1 and 2 service water start.
That's not A. That's only on the F signal.
Oh, yeah. RCC from trip. It says it's on 2 panels. 840 and 820.
Maybe there's something on of RCC in H0. I don't think it's simulated. So you can move on, it's just here. In game at least.
Circuit breaker 75/72 and circuit breaker 8582 tripped.
Yep, those are simulated and they actually fail to trip on the A signal, so you should take manual action.
Okay. Wait. Is Venemix supposed to be dead? It's not dead. And 8-5.
Yep.
Uh, how do I do this? The next step.
Motor controller 7 Charlie, 7 Echo, 8 Charlie, 8 Echo trip. And that actually failed. And that requires Vital Island. So let's run there. You would request an operator to do this. Brakeman,
Yes.
some stuff will happen.
Some
Is,
stuff like what?
Lights and stuff.
Is
Uh,
the motor power like the thing that controls the motors?
Question: will any essential systems be knocked offline for an extended period of time?
No, only non-essential. So that's 8 Echo. Let's find 8 Charlie as well. Here, 8 Charlie. And on the Division 1 room, 7 Echo and 7 Charlie. So 7 Echoes here. And 7 Charlie is here. Okay, we're done. Let's go back up.
Loki, I like the lights like this, bro. It looks better.
This should happen automatically. It failed to happen.
Oh.
Are these breakers like
I assume that's to conserve battery, but I don't know why battery would need to be consumed if we have the main turbine running, or conserved rather.
Yes, but dimming 2/3 of the lights also is a call for attention.
Oh.
This places the operators in high alert, basically.
I see.
reactor building ADR and FDR some stars it's on panel 632.
That's definitely not simulated. Dip is also not simulated. So let's go to the next one, SGT, which is actually simulated.
What's SC?
Standby gas treatment. It did start by these two. These two starting is indication that it started. What you can do, just start this, this, and this manually to match the flags. And this.
It started.
The flag is green. This is Division 2, do the same thing in Division 1. This, this, and this. The system actually auto started, so it's nice. Okay, very good. RB HVAC isolates and fan trips. RB HVAC is here. Isolation, isolation, fans, fans. Did it isolate and trip?
These are isolated, but
You can match the flag, yeah.
okay.
The actual thing tripped, you can just match the flag. It actually helps, it removes the trip alarm. So it's nice. Reactor building emergency room cooler starts. And reactor building lighting quenches. I don't think that is simulated. It actually is on this panel. So it's definitely not simulated. It's on panel 812. 813 is simulated though, CP and CSP isoplates. So
What are they?
containment exhaust purge and containment supply purge. But it's referring to the isolation valves. So these 5 and these 5. And they all closed.
Yeah.
So everything is isolated. Containment nitrogen makeup isolates. So this should isolate. It didn't.
So I isolated.
Yep. TR and TSW emergency filtration starts. This is actually simulated now.
Is it that?
Emergency filter unit.
What's TCR?
Hmm?
What's TCR? I mean
What do you-
this is
Technical support center. It's where the people with the big procedures will be. The ones that take hours to read. RCC isolates, that is right here. And the 5 valves are here.
okay, are isolated.
The last one is not simulated. So that is all. Ta-da.
So when CRS tells me to verify exhibitions, do I also perform them or make a sick list of what didn't actuate?
You should note what didn't actuate, yes. But you should also perform them.
Okay.
-50 is probably the biggest one because it's fast. But for the other ones, it's basically this and the thing Marcy posted. All right. Let's move on. Next thing, let's have Brakeman start BPM 5511. Brakeman,
Yes.
you're gonna be performing PPM 5511, alternative rod insertion.
Let me pull that up.
Read back first.
Perform PPM 5511, alternative rod
Yeah.
insertion.
Yeah, that is correct.
Uh,
Do you have it?
I don't know which one it would be.
What do you mean, which one?
There's 4 files that say PPM 5511.
Yeah, it's all parts of it. You should start where it says start.
It doesn't say start on any of them. Actually, let me look.
It might not be worded as start. Let me find it as well.
It's PPM EOP of PPM 5511 plus illustration plus ARI.
Yeah, it is the one that says PPM 5511 alternative rod insertion and has a big thing at the start, any control rod not fully inserted. That's the starting point.
Um,
Find that one.
yes, I see. Uh,
Read out loud. I'm gonna follow it with you.
any white RPS scram light lit. Then that would be no.
Pointed it. Where are those lights?
Oh, it'd be blue. On
you're not pointing the right
on my
one.
FCD, on my FCD.
It's this. These are the white scram lights.
Oh.
Here and here.
No.
No. So what do we do?
Remove one TB1 ARI fuse on P650 fuses 1 through 4.
The fuses are not actually simulated, but we can unpower ARI by unpowering the breaker. So let's unpower the breaker instead. It has the same function. It's Division 1. ARI should be somewhere here. Should say Atlas ARI.
Atlas plus
Yeah,
ARI Division 1 logic / solenoid.
Yeah, unpower that.
Circuit 11. Circuit 11. Circuit 11 depowered. Atlas and
Alright.
ARI depowered.
Next step.
Next step is remove one TB2 ARI fuse on panel 650 fuses 1 through 4.
Yep. So we're gonna do the same thing for Division 2 on the other side of the room. Come over here. Again, find the Atlas ARI.
Atlas ARI Division 2 logic / solenoid valve, circuit 10.
Yep.
Circuit 10 depowered, Atlas ARI Division 2 depowered.
Alright. Okay, what's the next step?
Next step would be some or all blue scram lights, valve lights lit. Let me check. Let me verify. Yes. If yes,
then
if yes, enter step B,
okay.
which would be
Find B then.
table B. Restore RPS B per ABN RPS. If unable, continue with driving rods.
Okay.
Let me open.
Is RPS Bravo powered?
One second.
We don't have a normal RPS, I'm pretty sure.
Okay. ABN RPS. All right.
We have it?
Let me see. No. We do not.
Okay.
Place STV high level trip control switch to bypass. Bypassed.
Yep.
Ensure both CRD pumps are operating. Both CRD pumps. CRD pump 1B started.
Yep.
Can scram be reset? Should I attempt to reset scram at this moment?
Look at the next step.
Look at the next step. Reset. Okay. Reset scram. If unable to reset scram, then manually drive rods. I'm unable to reset scram.
Okay, can scram be reset?
No. Override
Then?
RPS trip signals. Attachment 6.1.
Yep. The attachment is useless in game, so come over here. The attachment is for real life. This is our temporary scram bypass.
Override RPS trip signals. I believe I did.
Alright. Yeah. When you do in game, it's gonna have the lifted lead jumper. on the thing here. This
see.
wasn't here before.
I see.
Now,
Adjust CRD FC 600 and CRD V3 as
you're
necessary.
skipping step.
I'm skipping a step. Oh, reset scram.
Yeah,
Scram reset.
nice.
Uh,
Follow
adjust
the left side first.
when STV drained more than 2 minutes. Initiate manual scram. Should I
Is the
read?
STV draining?
No.
Is the valve opening?
No.
Yes.
Yes. What? Oh, yes. I see.
So you're gonna get a TD 120 countdown.
What did you just say?
Countdown 120, or stopwatch, or look at the clock, whatever you prefer.
Okay.
2 minutes.
Okay. That started the timer.
Okay. While you wait, follow the other side of the thing.
Adjust CRD FC 600 and CRD V3 as necessary to establish CRD drive header pressure.
Yep. This is the valve. Drive header pressure should be 230 pounds.
Confirm 230 pounds.
Yeah. Okay, continue.
Place RWM bypass switch to bypass.
Yep.
RWM bypassed.
Nice.
Manually drive rods as follows. Note, CRS may direct inserting clustered rods, 2 or more adjacent rods first. Start with 1043. Insert every other rod and every other row. Disregard edge rods. Starting with 1043. 10.
In game, you're gonna start with
1039.
1823.
1823. Okay.
It's because our core is much smaller.
Insert fully, correct?
Yeah. So the continuous insert. And remember, once the timer elapses, you're gonna scram.
Holy insertion
Okay.
time.
Okay, very important now. As the rods are being inserted, power will reduce significantly, and so your level will start going up. So remember to keep an eye on level.
I already let it exceed minus 107 by accident.
Out of curiosity, how much time remains?
I'd have to tab out. Let me finish this rod.
Why does manually inserting them work but not scamming?
What?
Why
Repeat.
are you able to manually insert rods but scamming fail too?
Those systems are independent. Water doesn't go to the same place.
Okay.
I can explain.
2 minutes has exceeded. Or elapsed.
Okay, then. Yeah. Then follow the other leg.
Initiate manual scram.
Now control level. It's gonna drop significantly. And then start raising significantly.
Why did the water level drop?
Power changed a lot.
Yeah, but why does that correlate to water level dropping?
because what feeds the reactor are based on the reactor steam. Have to trip the turbine, low power.
All rods are still not in. Is that acceptable at this phase?
Follow the thing.
Well, I'm kind of busy maintaining level to weight. All rods in? No. Further attempts desired? Yes. Raise STV drain time by 2 minutes.
So 4 minutes now, return to the top. Restore PS, bypass, ensure both CRD are operating. Can scram be reset?
Can scram be reset? I am attempting to reset scram. Scram reset.
Yes. Reset scram, wait 4 minutes now. So set a timer and then continue inserting rods.
Okay. So from now I would go to 2219, correct? In a checkerboard.
No.
No.
Every other rod, so
Oh.
skipping one.
Oh, every other. Okay, I see.
It's basically equal to the RWM.
Okay.
With the exception, you're gonna ignore all the edge rods. Also, really important you acknowledge the accumulator, because the accumulator trouble will also tell you if you have sufficient pressure to scram.
Can someone keep an eye on level for me?
How are you controlling level? Just this?
Yes.
So, the event that we're doing now is basically the most procedurally intensive event there is. So if you're able to follow these procedures, you technically should be able to follow any other procedure. We have a warning on IRM downscale, So I lowered 2 ranges.
Thank you.
So what do you think of this procedure, 5511?
4 minutes has elapsed.
Alternative rod insertion. Yes, cramp. All rods in.
No. All rods are not in.
Further attempts required.
Yes.
Desired.
Yes. 6
Yeah.
minutes.
Raised by... Yeah, 6 minutes, go back. Restore RPS, bypass STV, ensure both pumps running. Can scram be reset?
Yes.
Yeah. Timer 6 minutes now.
Active.
Continue the rods.
Why does it never get this far in real transients? Why does it not get this far in
'Cause
community transients?
because he's trying to make my life difficult.
What do you mean this far?
Like they usually end sim before they fully insert the rods.
Because usually they fuck up badly.
Oh, like I just did?
What do you mean? That is not necessarily a problem. It's not like you're gonna be withdrawing the rod, just get the next rod and move on. This is not procedural, but you can also ignore rods that are on notch 2. Like, for example, this rod. Ignore this rod. This rod, ignore this rod. This rod, ignore this rod. Because rods that are on notch 2 are considered shutdown. So there's no point in wasting time with them when you have rods on much higher powers to worry about. Make sense?
Yeah. Six minutes has elapsed.
Nice.
All rods are in.
All rods in.
So all the following fuses removed in Table A. TB1 ARI fuses and TB2 ARI fuses.
Yep.
Okay, so I'll just go reset those breakers in.
Yep.
Only took, what, an hour and 18 minutes? Division 1 repowered.
I'm gonna be going now. So
Okay.
yeah. See ya.
Bye-bye. Division 2 repowered.
Bye bye.
Finally.